In this video, I'm trying to show you some examples from compound inequalities, which is what this lesson is all about. And we're talking about either and or problems. So let me start with the first examples, which are and problems. You have two different ways of being presented with an and problem. One way is you can have it as two combined problems together. So here's half of the problem, and here's the other half. And you can do it all together in like one problem. So for example, your x is in the middle and eventually you want x by itself. So the first thing is you have to get rid of that positive 4. So I'm going to be subtracting 4 from 3 sides. Be careful, 3 sides. Because you have to keep the balance. Even though it's not an equation, you still have to keep the balance. Negative 3 less than or equal to 3x, if I clean that up, which is less than 9. My last step is to get rid of the factor of 3, so we'll be dividing all 3 sides by 3. 3 is a positive number, so I don't have to switch anything. Negative 3 over 3 is negative 1, which is less than or equal to x, which is less than 3. I'm going to box this because this is my answer. And usually in inequalities, we're asked to graph because it's very interesting to show the solutions on the number line. So of course your number line should be straight. And let me go ahead and put some numbers in there. Negative 2, negative 1, 0, 1, 2, 3, and so on. And according to this is telling me, if I'm trying to interpret it, that x has boundaries and it goes from negative 1 to 3. So let me grab another marker to show you. Because at negative 1 I have less than or equal to, that tells me that I can include that boundary, which means I have to put closed circle. At 3 though, I don't have an equal sign, which is telling me I can't include that circle. I can't include that value, so open circle. So closed versus open. And according to this, x can be anything between the two values. Shading means solution. So if I choose any value within the shaded area and I put in the original problem, the red one, it should be working. So the solutions are within the shaded region. That is one way that you can have an and problem. Let me go to number 2. This is an and problem also, but it is separated for you into 2 parts. So let's go ahead and work on that. I'm going to do them separately, so let me deal with this first. I still want to get x by itself. So, I'm sorry, not plus 1. It should be minus 1. There we go. Minus 1 on both sides. So that gives me negative 6x greater than negative 6 because I'm adding 2 negatives. And at this point, I have to divide by negative 6. So because I'm dividing by a negative from here to here, I have to remember to switch the inequality symbol. So that's half of my answer. Let me go to the other half. Minus 4, minus 4. So that gives me 3x greater or equal to negative 3. Now I'm dividing by positive 3 because I want to get the variable by itself. So that's the problem. So that if I clean that up, I'm having x greater or equal to negative 1. I'm going to box this because that's my answer. Now, I'm allowed to, when I have an and problem, to take this boxed answer and put it under one statement, which is what I had before. You don't have to, but it's easier for you when you make your number line. So this is telling you, because it's an and problem, x has boundaries, it's in the middle. The biggest boundary is 1, and the smallest boundary is negative 1. So take it from the smallest to the biggest. I did not switch anything. This is telling that x is greater or equal to negative 1. And this is telling you negative 1 is less than or equal to x, which is the same thing. So if you go from this box to this is helping you to make your number line easier for you. All right, let me put some values. It should be a straight line. Negative 2, negative 1, 0, 1. At negative 1, I should be putting a closed circle. Closed circle. At 1, I should be putting an open. This statement is telling me anything between the circles is included. So there is my shading to show the solutions. Anything that you choose from the shaded area should be working. If you choose something outside, it should not be working. And you can try that. You can test that by yourself. So that is how an end problems look like, two different ways. But we expect for the most part, unless we have a weird case, the graph to be looking kind of the same. We have the circles and the shading is happening between the circles on a normal end problem. Let me shift gears now and go to an OR problem. So let me go to number 3. All right, number 3. OR problem. For the OR problems, you have to have two different statements. So it's really two problems separated by an OR. So let me go and start the left side. I need x by itself. So that should be the first step. Be careful here. You're adding two negatives, so more negatives. And you're dividing right now by a -5, which means from here to here, flip. Don't forget, flip the inequality symbol. Or let me go to the other side, x by itself. So get rid of the -4 by adding. 6x less than or equal to 6, divide by a positive, and you have your answer. X is less than or equal to 1. So this is my answer. I'm going to box it. Unlike the end problems, the OR problem, I cannot put the inequalities together. It's like this. That's it. So let me go ahead and put this statement on the number line, graph it. So let me put my numbers 0, 1, 2, 3, and so on. And let me go with another marker. So this is telling me open circle of 3, open, and shade to the right. This is telling you closed at 1 and shade to the left. So you can clearly see a big difference between an AND and an OR problem. With an AND problem, the shading is between the circles. With an OR problem, a normal OR problem, the shading is outside. You can have very few weird cases, but for the most part, this is what you're looking for. Number 4 is another OR problem. It's another OR problem. Sorry, another OR problem. So let me get started. Divide by 12 to get x by itself. 12 is a positive number. Here's half of my answer. Here I have division, so I need to multiply both sides by 7. 7 is a positive number. So I'm getting x is greater than 21. So here's my answer. Number line. Now looking at your numbers, you see that maybe you shouldn't go by 1s here. So maybe here I'm going to go by 5s because there's a big spread between the numbers that I have to show. 15, 20, and 25, and that's going to do it. I need another marker to show. This is telling me at 3, which should be right here, closed, and go left. This is telling me at 21, which is right here, open, and go right. Again, this is how, generally speaking, an OR problem should be looking like. The shading is happening outside of the circles, outside. Similar to before, anything in the shaded area works. So if you grab 0 and you put it in, you should be getting a true statement. Let's try it. If you put 0 in here, you're getting 0 is less than or equal to 36. If you put 0 in here, you're getting 0 is greater than 3. It doesn't work for this, but it works for this. So remember, with an OR problem, it has to work for one and you're good to go. So it works for this, it doesn't work for the other. Same here. If I get 25 and I tested, 25 would be working for this, but not for that. But because it's an OR problem, I'm covered from this and I'm good to go.